If you've followed my videos for a while, you know that I have definitely leveraged these PSoC kits. This is a prototyping kit. It's a 5LP PSoC prototyping kit. And this kit, when you open it up, basically just has one of these in there. And what you're seeing here is essentially a little development board, a prototyping board. And technically there are two different PSoCs on this. There's the main PSoC over here, and then there's also maybe a lighter weight version of the PSoC on the left here that's used to program the main PSoC. And what you normally would do is snap this apart. And what I've done on many of my projects is put pin headers in, and this just sits into my main project PCB board, whether it's a 286, 386, 486, whatever it might be. Well, more recently, as I've been working on my 486DX build or DX2 build, I've wanted to see if I could take the PSoC off of this board and put it directly on my main 486 PCB. And with that comes many challenges, I think. But I did go out and I built some PCBs. And so now I have these little PCBs that the idea is I should be able to lift off one of these, let's say the main PSoC here, and drop it right here. And with this is just a little board to let me do some testing. You know, can I route my signals into this tiny little package? Can I maybe light up some LEDs? Can I program it? You know, so can I take another one of these programmers like this here, which was from another PSoC, and plug it into my USB and take this little header and jump it over to the matching header here? And can I program the PSoC on this PCB and just do some basic testing with it? And it's really a test of my PCB skills in routing and going to smaller traces than I've typically done. Also, it's going to test my soldering for this type of package that I'm going to have to use to solder this on. And then also I've got some things on the back, like small little capacitors that are underneath. So that'll be interesting to see if I can make all of that work. Now, you know, my main PSoC I've been using is this one on the right, but the one on the left, like I said, is just a version that's a little bit lighter weight. Same pin out, just maybe not as fast of a processor, things like that. So what I thought I could do, at least for practice, you know, I've got a whole stack of these broken off left-hand side pieces that, as I've been using the right ones, you know, these just pretty much have been collecting. So these might be a good test to see if I can desolder and solder it onto here and then try to make it work in this little utility test board. And if I can do that, that gives me some confidence I should be able to transfer this to a larger actual, you know, project I'm working on, not just this little test board. And if that, you know, goes okay, I then might also step up to this PCB. Now this PCB is going to leverage a totally different package. It's the same family, this PSoC 5 chip, but it's a larger package that has more I/O pins. And so on a previous project, I might have a pair of these on my 486, for example, that I'm going to try to consolidate down into a single PSoC plus some of the other logic on a typical 486 board. So this will come later. Right now, I'm not so worried about that. What I want to first of all, though, do before I start messing with these, because these chips aren't inexpensive. They're not super expensive, but they're not inexpensive. And let's say $15 US each. I don't want to mess those up until I have some confidence that I'm going to be able to essentially use my own little board, put a PSoC on it, program it through the header, and if that works, then I'll step up and try it on this board with this chip. You know, I've got all of these that I'm not so worried if I destroy those in the process. Different package, you know, of course, but, you know, as far as how small the footprint is, I think this one's actually going to be easier for me to work with than this one, because this one seems like it's even smaller as far as these pads are concerned to get this little chip put on there. But anyways, that's what I'm going to try to do here. And so I think step one for me is to try to remove one of these. And that's what I'm going to do here. So I think the first thing I'm going to do with that is just jump over to my workbench here and pull out Microscope. And this is a microscope that I'll be using as I go through this. Now I've set this up so that I can switch between this backed up view that you see here to a slightly zoomed in view all the way in to look at what's underneath my microscope here. So I can take a look at this like so. And there's some little lights here that will help me see this a little bit better. And so then I can turn this and I can just see there is this specific chip. If you can see that, it's a CY8C 5868, whatever it might be. And if I come back and I look at this board, there I can see that that is a CY8C 5888. So those are the two PSoCs, same pin out, but I'm going to use this one here for practice because I have a lot of those that I haven't been leveraging. And so I need to pull this off. Now I can look at this and kind of see, how do they have it mounted along with the capacitors that go around it. I can flip over to the back side and just see, what's on the back side, how they place the different capacitors. So I can kind of get an idea of that. And then of course, if I go to my little board, looks something like this. I have no capacitors on the top, but if I flip it over, I'll see I've got all those capacitors either right underneath it or very close surrounding it here. But I'm going to see if I can pull this off successfully or not. And I think to do that, if I back up here, I'm going to leverage a hot plate. So I have just a standard hot plate here used for these types of PCB projects. I'm going to go ahead and turn it on and let it start warming up as I'm talking here. And I think I'm going to have to pull my microscope up a bit. So for now, I did cover the front of the microscope screen here. Instead of using the screen on this, I'm just using an HDMI cable that goes to my PC that's capturing all this. And I covered this up because the glare was quite distracting, actually. But I'm going to set this hot plate underneath and see if I can flip over to that and get this in focus. And so I'll go ahead and get this little guy underneath there and try to get this so that we can see it. Okay, so that is what I'm working with here. And my goal isn't necessarily to have the hot plate so hot that parts are falling off. I'm just really trying to give it some heat, and then I'll use my hot air gun on top of it and try to pull this off. So I'm going to go ahead and get myself some tweezers. And as I'm working on this, I might want a second set of tweezers, and I'm going to go ahead and just get some flux around this. This is the first time I've ever worked with this type of a package, so this could be quite fun. And I'm going to give this just a little bit of time to heat up. And I'm going to get my hot air station going. And while I'm doing this, I'll just comment the rest of this little board, whether I lose some capacitors off of it or there's a little status LED, things like that. I'm really not worried about. The rest of this PCB, as far as I'm concerned, is pretty much a throwaway. Okay, I have that off. And so if I just flip this over real quick, I'm going to pull this out of the way. But here's this
little IC I pulled off. And if I flip it over, you know, I can see that I pulled a cap with it. So a couple caps actually. So those I'll want to get off here in just a second. So I think that looks okay. I don't think I've damaged this in the process, but we'll find out. I'm going to pull it off for now and set it aside. And so now what I might do is get this PCB I'm going to work on here onto my hot plate and try to get it into the camera here. So I got something that looks like that. And I think I'm going to put a bunch of flux on that and probably just run over this with some solder. And this will definitely take some practice for me. This is really small. I know I watch others do it on YouTube videos and they make it look so easy. And I probably have a little bit too much here in the center, so I might try to pull a little bit of that up. Okay, that for me, I think I'm good with. So now I need to find this little chip and see if I can find out which corner of it is pin 1, which I'm going to assume. I'm going to go actually look at the drawing on the computer here in a second, but on my PCB that I built here, you can see that I put pin 1 there on the lower left, right down here. So let me real quick just pull up this and see where pin 1 is at. And so what I'm doing here is just going to clean the top of this off a little bit. And yeah, it looks like I've got a dot there in the upper left. That might not come through real well, but so what I need to do then is get that dot oriented. Okay, so I want to try to get this just kind of close, and then I will go ahead and start heating this up. What I need to do next, I'm going to turn off my hot plate and turn my meter on. And I can pull my hot plate off to the side for a second. Okay, I do see the dot there, so I think I've got pin 1 to pin 1. And I think from here now I can go ahead and solder in other parts of this that I need to put in. So if I back up here a little bit. My understanding is on the side, there are some tiny little spots to check that the bottom ground underneath actually is connected to ground. And might be really hard to see here, but I think there's one of those. It's right here. There's one, couple on each side, I think. So I believe I can touch to that and then see if I can have continuity to ground. So I'm going to try that. Okay, so I'm going to go pull up the schematic for this real quick. So this is the schematic, and if I look up here, I've got a ground right here that I can just touch. So right here. And then the question is, if on here, I can get into this other little. Okay, so I am getting that little pin is connected to ground, which tells me that underneath this, that did solder, and or at least is making contact enough. And you know, these maybe aren't looking perfect, but I'm not going to complain with what I've got here so far. So what I need to do is run around this and see what else do I need to plug in. And so I've got power up here, and I have a capacitor that I'm going to want to have for that, just coming into that. Let's see what else I'm going to need to come down here and put in some pins here that will let me hook up the programming port. And I've got a bunch of these headers. Now these, instead of 2.54s, I did 1.27s. And they look nice and big on the microscope, but they are definitely noticeably smaller. So I'm not sure if I'll use those, but I thought I would just experiment with that. And then way up top on this, I have some spots for LEDs and some resistors. And if I come and look at it here on the computer, you can see I've just connected to some different ports, 15, 7. So basically this is port 15, 0. I run through a resistor and then through an LED. And so what I'm going to do at this point is just kind of try to get some of this stuff soldered on here real quick. So just for now, I'm going to grab just one of these little boards that I've been using in the past. So this board just lets me bring in banana power, and then it's got headers of different types, and I can just grab a regular positive negative header with a couple wires and jumper that over. Okay, so I'm going to plug in my VCC, my ground, plug this in. I did get a new benchtop power supply, so this will be the first time I'm using it. And I'm going to switch this to off and turn my power supply on. And while that's turning on, I need to go positive and negative from there to here. Okay, so I have my power supply set to 5 volt, and I turn on the output, and I can see I'm getting this LED just showing I'm getting 5 volts into this, which is good. And then as I turn this on, I'll get the other 5 volts, and I got clock and other things running. But okay, so I've got my power coming to this, okay. And I'm going to go ahead and just plug into a header here for power. So this is after the switch. And so I've got my black going to ground. Okay, so just pausing for a second. So power's coming in, and I have my power supply set to exactly 5 volts. And maybe what I'll do is just see, normally these cables I drop a little bit. Let's see what I've got here just to check. So yeah, that's coming through pretty well, 4.99. So I'm really not losing much getting up to this. And I'm going to go ahead and turn it on, and I'm hoping to see that light up and not any fire or smoke. Okay, that looks good. And so at this point, I am looking at my power supply, which I'm not going to show on the video, but I am pulling 0.3 amps, and probably because a lot of this is running, I can probably turn off
I'll just flip my clock to manual and get that LED off. So 1.5 watt or 0.3 amp at 5 volt. I'm just going to see nothing hot there. Okay, so maybe what I have so far isn't treacherously bad. So next thing I need to do is see if I can open up the software for building the logic in one of these chips. And I'll do something like a really simple little timer. I do feel it may be warming up a little bit, so maybe that's a good sign. Maybe not much, but then if I get that software configured, maybe with a really basic little, just a timer, and I'll flash this LED, see if I can program this. So I'm going to stop here because this video has already gotten pretty long. But so far I've got my PSoC on. Whether or not I've got it on well enough to work, we'll find out. And I have enough coming in here to get this power LED lit up. And my next goal is to program the PSoC and see if I can flash this LED up here. So stay tuned for the next part of this.